Okay. So now let us consider the following example. We have string s1 with the value of spring. Then we are concatenating fall to the spring. Then we have string s2, which is the result of concatenation of when we concat string summer to the string spring, and then we concat winter to s2, and then finally we print both the strings. So try and guess the output of this program. So so let us try execute and take a look at the output. Okay, so we are getting the output spring and spring summer. So the value of string s1 is spring and the value of string s2 is spring summer. So let us take a look at this program. So we have the first line, string s1 equals to new string spring. So according to our first thumb rule, an object will be created, new keyword is used, so object is created inside the inside heap. So an object, the value of spring gets created inside the heap, and we have a reference variable s1 pointing to it. Then in the second line we perform concatenation on the string s1, so we concat fall to the string. So as it is a runtime operation, it will only be inside the heap, and the new object's value would be spring and fall. So we now have a string with the value spring fall. Since there is no reference variable that is being assigned to object written by this statement, uh, it would go for garbage collection automatically, but that's not our concern right now. We are considering the objects created inside the heap. So S1 still points to the spring, and spring fall is a new object created inside heap. Now we come to the third statement, string s2 equals s1 dot concat summer. So now we have to perform concat on the string s1. So now think carefully for the value of s1. I just said s1 still points to string because the concat operation of the second line returns an object which isn't assigned to any variable. So it goes for garbage collection. S1 still points to the string spring. So we now have an object which is the concatenation of spring and summer. So now we have an object with the value spring summer inside our heap, and then the next line which is s2 dot concat. So we have our s2 reference variable pointing to this object spring summer, and then we have a line s2 dot concat. So the value of s2, just as we saw, s2 is pointing to the object spring summer. So a new object is created inside heap with the values of spring, summer, and winter. So we have an object, and just as we saw in the case of s1.concat, since it returns a new string value and no variable is assigned this value, it goes for automatic garbage collection. So now we have taken a look at the heap side. Now let us consider the SCP side. So in such programs, when we have to determine the number of objects formed. So these questions are commonly asked in the multiple choice based exams. In the even the SCJP and OCJP exams, these types of questions are common. So whenever we have to form the SCP side, the SCP only has string literals. So whatever string we see in double quotes, it always goes in the SCP. Nothing else goes inside the SCP. So we would just take all the string literals and direct create objects for them inside the SCP. So we have first one as spring, then we have second one fall, then we have third one summer, and then we have our fourth one as winter. So in total here, 8 objects are created, 4 inside the heap and 4 inside SCP. So I have told now an easy trick to figure out objects inside the SCP. Whatever value is given inside the double quotes, it directly goes inside the SCP. Nothing to think left and right there, because SCP always hold literal values. So all the literal string values inside a program will go inside SCP. So these all four values go directly inside the SCP, and we have seen the object formation and the variable pointing inside heap. So let's move on. This is the same program, and then as we have seen now, S1 points to spring, and then spring fall, then S2 points to spring winter, and then spring winter summer, and the objects, four objects inside SCP. Now let's take a look at conclusion. You might want to pause and read or even note down this. So the total 8 objects will be created, 4 inside heap and 4 inside SCP. And line 1, spring is created inside heap and spring is created inside SCP, and variable S1 points to spring inside heap. Then line 2, spring fall is created in heap and fall is created in SCP. Then line 3, spring winter is created inside heap and winter is created inside SCP, and S2 points to spring winter in heap. This is this statement. S2 SI string S2 is S1 dot concat that we are seeing here. Line 3, S2 points to spring winter in heap, and then line 4, spring winter summer in heap and summer in SCP. So in last we are printing S1 and S2. So both so S1 points to spring and S2 points to spring summer. So let's run again, and get the same output as we got before, and we have seen the derivation of the output. So let's move on. Now I have to discuss an important point regarding SCP and heap and runtime operations. So let us consider the following example. It's a simple example. So what we have done is we have taken a string with value hello, then we concat world, and then s assign s dot concat cat. So we have seen this example code before, but let's take a look. Last is s dot concat. Right, so we have this code, and when we run this code, you should be able to guess the output now. So okay, we just did a syntax error here. Sorry for that. Okay, so we get the output hello, and our initial code was not that s assign s dot concat cat. Okay. Yes, now we get the proper output hello cat. So we have seen the earlier example in the previous video, the derivation of hello and cat, but now let's take a look. So this side we have heap, and this side we have SCP. So when the first line of code is executed, according to both thumb rules, objects get created, new keyword is used, so object gets created inside heap. hello inside heap, and variable s1 points to it. Then since we have used the literal value hello, so in SCP also it would get created. Okay, now pay attention. Since we are doing concat s1 dot hello world, so since we have used world, so world gets created inside SCP. Literal world gets created inside SCP. Okay, and now the concat operation s1 dot concat hello, and then we are concatenating world, so world gets concatenated to the string hello. But hello world, the resultant string isn't created inside SCP, it only gets created inside heap. So you might wonder why doesn't it get created inside SCP? So here the basic rule of SCP is to be remembered that SCP only contains literals. So literal values are here, and this s1 dot concat, even though hello is used as a literal and world is used as a literal, but the resultant string hello world uh, is the result of a runtime operation. The s1 dot concat, this is a runtime operation of concatenation of two strings, so it is performed at runtime. So the results of runtime operation do not get stored inside SCP. They are treated as dynamic objects and they reside only inside the heap. So the string hello world, like we have seen before, gets created only inside heap. String s1 inside heap, and then we move on. Then s1 dot concat cat. So we have the literal. So the literal gets created inside heap. Sorry, literal gets created inside SCP, and then the string of resultant string hello cat, the result of concatenation, get created inside heap, and then we have s1 pointing to the newly returned object. So s1 now, s1 doesn't point to this hello, s1 now points to this new string hello cat. So when we try to print this, we'll get the output as hello cat, because we are trying to print s1, and in the end the final value of s1 is hello cat. Just we have seen here, final value of s1 is hello cat, and hello cat reside inside the heap. So total 6 objects get created, 3 inside heap and 3 inside SCP. So I hope that's clear. The point of this example was to explain that runtime operation objects do not get created inside SCP, even though both the strings are from literal values. Here both strings hello and world are given to the program as literals, but the operation of concatenation is a runtime operation, so its result hello world won't be created inside SCP. So this is an important point to remember. So let's move on. See, at line 2, a string hello world is created inside heap during runtime. So you might wonder why that string does it get created inside heap and not in SCP. So s dot concat world is dynamic runtime operation, just as I said, and output it produces is not a literal value. Even though both the strings came from literals, it is not a literal value, so it doesn't get created inside SCP. It's a result of runtime operation, so it gets created inside heap only. SCP inside SCP objects do not get created as a result of runtime operations. Only literals, only values which are given like this in double quotes are get inside SCP, nothing else. So let's move on. So now let us consider another example. So now let us consider this example. So let us take a look. So we have string s1 is new string. We are using the new operator is you cannot change me. Then we have string s2 its value is you cannot change me. So by looking you can tell that both string s1 and s2 have same content but are different objects. You should be able to differentiate it by now. And then system.out.println s1 equal to s2. So try and guess the output of this statement. Guess the output of this highlighted statement s1 equal to operator s2. So what would be the output of this statement? True or false? So let's run and see. So we get false as our output. So why do we get false? Let's see that. So first line string s1 equal to new string. So we have new used the new operator. So object gets created inside heap. So we have you cannot change me inside heap, and the reference variable s1 points to it. And we have s1 pointing to it, and since we have used a literal value, so it would get created inside scp2. So you cannot change me. Just ignore this exclamation mark for now. We'll only consider the strings. So you cannot change me both in heap and scp, and s1 is pointing to the object in heap. So now we come to line number 2. Here this is the second statement. So we have string s2 equal to new string you cannot change me. So since new keyword is used, object gets created inside heap. So inside heap we have an object with the value you cannot change me, and the variable s2 is pointing to it. So we have the variable s2 pointing to it, and then since literal is used, JVM will go into the scp for creating an object for the literal value, but it will check before creating, and the exact same value you cannot change me is present inside scp as the result of the string s1. This first line execution, so the string you cannot change me already exists inside scp, so it won't be created again. Okay, so now we have two strings, and then we have equal to, we are comparing s1 equal to s2. So here, as I have told in the previous video, equal to does reference or address comparison. So it returns true if two objects point to the same memory location. So here s1 equal to s2. So here as we can see, s1 points to different object and s2 points to different object in heap, and hence we get the output of this statement as false. Yes, we get the output as false. Okay, that is clear. Now let's move on. Okay, then we have string s3. So string s3 you cannot change me. If you look carefully, string s3 also has the same content as the above two strings. So new so it is a direct literal assignment. As you can see, no new keyword is used. String s3 is directly assigned a literal. So as per a second thumb rule, JVM, the string value would get created inside SCP. So JVM enters SCP to create the string you cannot change me, but before creating it checks, and since the value you cannot change me already exists, so it just returns a reference to it, and now string s3 points to SCP, the string you cannot change me from SCP. Okay, then now we have s1 equal to s3. Now we have the statement s1 equal to s3. So now let's run it and see the output. You should be able to guess the output. So the output is false. Let's see why it is false. So S3 points to the object inside SCP, and S1 points to object inside heap. So these two point to different objects, and since equal to does memory comparison or memory address comparison, these both addresses, the addresses pointed by both of these variables are not same, and hence it returns false, and we get false as our output. So now let's move on. Then again we have string s4, you cannot change me, it is a literal assignment. We have string s4, you cannot change me, and it is a literal assignment. So it gets created inside SCP, and since it already exists, a new reference variable to it is created. So now s4 points to the string you cannot change me inside SCP. So now we have s3 equals to s4. So you should be guess the output, and it should be correct. So let's see the output. Yes, we get true as our output. So let's see why we get true. So S3 and S4 point to the same object inside SCP, and since equal to does a memory address comparison, and both of these variables are pointing to the same object, and so we get true as the output of our statement. So let me just write the output here. False here, and in the first case also we got false. Okay, now let's move on. Okay, now pay attention. This is an important case to be considered. So now we have string s5 equals to you cannot plus change me. So this is a concatenation operation on string using the plus operator. So whenever we use plus operator on two strings, they get concatenated. It is same as the concat method we have seen earlier. So here we have you cannot plus change me. So try to guess the output of this string s5. So you might think that since the plus is there, it is a runtime operation, and this string s5 gets created inside heap only and not in SCP. But here we have to take into consideration an important point. So let me just write it. So Java, in Java operations on constants are performed at compile time itself, and not at runtime. So in Java, operations on constant values or constant variables are performed at compile time itself and not at runtime. So I'll repeat, it is important. In Java, operations on constants are performed at compile time itself and not at runtime. So let's see what that means. So the string you cannot plus change me, so we might think that these two get concatenated at the runtime, but no, since we can see that these both you cannot plus change me are constant values, they are literal values, and you can see that the value is constant. It won't change because we have hard coded the value. So these are two constant values, and the concatenation operation is performed between those two. So such operations on constant are performed by the compiler rather than at runtime by JVM. So this improves performance. So it is important to remember that operations on constant are done at compile time. So I have discussed this in the later part of the video. So let's take a look further. So now we have you cannot plus change me, since these are two literal values. They both get created inside SCP. So we have you cannot, then another. So we have the string change me inside SCP, and now that it is created, the concatenation operation of you cannot plus change me here. you cannot plus change me is performed. So you cannot change me, the JVM would go inside SCP to create the object, but first it checks whether it exists or not, and hence, since you cannot change me already exists, it would return a reference to the existing object. So S5 point to the existing object. So uh, here S5 is you cannot plus change me, since these both are constant values, they get added at compile time, and S3 equal to S5 should give us true, and yes, we get true because just now as we saw S3 and S5 point to the same object. So now moving on, we have string S6 as you cannot. So since that is it is direct literal assignment, so it would be get created inside SCP. So as inside SCP you cannot already exist, so it won't be created again, and a reference to it would be written. So S6 would now point to the you cannot object. So S6 points to this you cannot. So S6 points to you cannot. Then here we have S7 equal to S6 plus change me. So you cannot plus here S6 plus change me. So try to guess the output of this. So you might think that S6 is you cannot and change me is constant. So since both are assigned literal values, it would get executed at compile time. But no, since S6 is a variable and not a constant, the value assigned to S6 is a constant value, but the variable S6 itself is not a constant. S6 can be changed here in between, so I could just write S6 equal to cat, and it would perfectly be valid. So S6 equal to S6 plus S change me, it won't be executed at compile time, and it is a runtime operation of concatenation. So whenever a variable is involved, it is a runtime operation, and whenever constants are involved, it is a compile time execution. So let me write whenever variables are present inside an operation, it is a runtime operation, and whenever constants are present inside an operation, it is a compile time operation. So whenever variables are present inside an operation, it is a runtime operation, and whenever constants are present inside an operation, it is a compile time operation. So you even if one is variable and one is constant, so the first rule holds true, that since a variable is present and its value can change, so it is not a compile time. If both are constants, then only it is a compile time operation. So this S6 plus change me is a runtime operation. So the object would get created inside heap. So in heap we will have an object of you cannot change me value. So here you cannot change me, and we have the reference S7 pointing to it. So now S7 points to you cannot change me object inside heap. So further we have S3 equal to S7. So when we run this, you should try and guess the output. So let's see the output. Okay, we get false as our output, but let me comment the above print statement so we have better clarity. So we get false as our output of this statement S3 equal to S7, because as we can see here, S3 points to object you cannot change me inside SCP, and S7 points to an object inside heap. So since equal to does reference comparison, and both objects do not point to same memory location, hence we get false as our output. So I hope it's understood. Now let's move on. Now this is an important case. Here we have final string asset is you cannot. So as we know in Java, we can make constants using final keyword. So using the final keyword, we can make constants in Java. So here we are creating a constant. So final string asset is you cannot. So this asset is now a constant, and here string s9 equals asset plus change me. So in the above case, for a variable s7, we saw s6 plus change me got executed at runtime because s6 was a variable. Now since asset has final, since asset is final, its value cannot be changed at runtime, and it will remain constant. So asset is now a constant, so final variables are constant, so please remember that. So here asset would be directly treated you cannot plus change me, so this statement would be you cannot plus change me, and just as we saw above, this would be a constant operation since asset is a constant and not a variable, and change me is a literal. So but first, while execution of this, it would create an object of you cannot inside the SCP, since this is literal assignment. So it would go inside SCP for creation of asset. Since you cannot already exists, it would assign a reference of it to asset. So now asset points to you cannot, and then change me. Since change me is a literal, it would to be created inside SCP, and here we can see it already exists, so it isn't created again. And then the constant operation of you cannot plus change me, so it results in you cannot change me. So JVM would go to create the result inside SCP, but since you cannot change me already exists, a reference to it would be returned. So the S9 2 now points to the string object inside SCP. So S9 also now points to the object inside SCP. So here we are checking S3 equal to S9. So since equal to does memory comparison, and here S3 and S9 both point to the same variable, we would get true as our output. So yes, we are getting here true as our output, and then we have S6 equals to S8. So since S6 is you cannot plus S8 is also you cannot, and as we can see here, S6 and S8 both point to the same variable inside SCP. Even though S8 is final, its final nature isn't concerned here. We are checking whether they point to the same memory location or not in here. And just as we saw, they point to same memory location. So we would get true here. And yes, we get true. S6 equal to S8, we get true as our output. So let's see, in total 3 inside SCP and 3 inside heap. So total 6 objects would be created, 3 inside heap and 3 inside SCP. So here this is the same program, you cannot change me, and here is the diagram. So S1, S2 and S7 are created inside heap, and for a single string you cannot change me, there are 4 references created: S3, S4, S5 and S9. S3, S4, S5 and S9, just as we saw. And for you cannot, there are 2 S6 and S8, S6 and S8, and for change me there is no reference. So As you can see here, and you can try and understand that we are now getting the idea of the purpose of SCP's existence. So it is discussed in detail in the further part of the video, but just take an idea that here four objects point to the same, four references point to the same object. So here ultimately memory is saved. So let's move on further. So this is some must remember high importance point. So this is a constants operation. So in any operation, if both operands are constants, then the operation is performed by compiler at compile time rather than JVM at runtime. This I just explained. So if we have int a as 10 plus 10 20, since both these values are hard coded constant values, so this would be get executed, so the addition would be performed at compile time rather than runtime, and at runtime JVM will see that int a equal to 30. So it would say like this: since these both were constants, the compiler did the addition operation on constants and sent a equals to 30 to JVM. And final variables are treated as constants, just as we saw now. Here asset is a final variable and it got treated as a constant. So final variables are treated as constants. So if any one operand is final and one operand is constant, both are treated as constants. We saw this case here. If any one operand is constant, asset is constant, is final. Any one operand is final and another is constant. So change me is constant and asset is final. So if any one of operand is final and one is constant, both are treated as constants and the operation is performed at, okay, it's just a mistake here, it should be compile time. So just as we saw, both operations are performed at compile time. So here, if we execute the example final int a plus int b, then we would have this operation, this whole operation would be performed at compile time rather than runtime. So the above operation gets performed at compile time only. Okay, so I hope it's understood. Now let's move on to the further point, importance of SCP. So till now we have been seeing a lot of heap and SCP stuff, but you might be wondering that what is the use of SCP. So let us understand the use of SCP by a case study. So case study to understand the use of string constant pool SCP. So as we have seen in earlier video, strings are most commonly used objects. So let us consider an example of voter registration form. So for voter registration form, we might have the following details of user. So we would need the basic details of the user. So name, first name, last name. These would be as strings. Then the address of the user, house name, street, town, city. This would be also string. Then gender, it would be string. Then age and mobile number would be integers. Okay, so here we can see of our 80 to 90% rule, that 80 to 90% of all objects in an application are string. Okay, so now let us consider the voting registration form. So suppose we have a user U1 and your user U1 is filling out the form. Okay, so we have the user U1 and user U1 fills out the form. So all the details mentioned in the form would be filled. So here stuff like name and city and everything. So here there is a field city for the user to enter. So now suppose the user one enters its city as Mumbai. So let's see here. So in the above example, almost 90% of all objects used as string. So suppose one user enters his city as string. So now is city as Mumbai. So in So one user U1 entered his city as Mumbai. So now in Mumbai there are millions of voters. So when millions of voters registered, they will enter their city as Mumbai. So we would need millions of variables, millions of string objects to hold the value of Mumbai. So just to hold the repeated value Mumbai, we would need millions of objects if we follow the standard, if we create a new object for every time, every variable. So as we can understand that that won't be inefficient, and there would be the problem of data redundancy and memory wastage. So redundancy, data redundancy simply means that data is repeated unnecessarily, and memory wastage, as we can see that if we create one, suppose there are 1 million objects. So if we create 1 million objects of city Mumbai, then that would simply be a memory wastage. So here the concept of SCP is useful. As we saw in the above example, here single variable, single object you cannot change me had four references to it. So this ultimately saved memory, and in this case the purpose of SCP is same. So this is the sole purpose of existence of SCP, that all the constant hard-coded values are saved, and if the value is to be reused, then a reference to it is returned rather than creating a new object, because this approach of SCP is more efficient. Okay, so now consider application of SCP. Just as I said, it will store only one copy of cities inside the program and give out references. So it can give millions of references out, and references don't consume as much as memory as a whole a string object. So ultimately our memory is saved and our program becomes more efficient. So there is another thing, another case to consider. Now if the user one who entered his city as Mumbai changes his city to Pune, then the object, this city object was originally associated with the user U1. So if U1 changes and the value gets changed, the Mumbai here gets changed to suppose Pune, then if the user U1 had right access of this object, if the user U1 could change the content of this object, then the 1 million references pointing to it, their city would also get changed, causing a big problem. So to solve this, SCP is read only. It means that the object's data inside SCP cannot be modified. So when user U1 tries to change his city, a new object would be created with the value Pune, and user U1's city would be assigned a reference to that new created object inside SCP. So I hope this is understood. Okay, so now moving on, final versus immutable. So final versus immutable is an highly important question from interview perspective. So make sure you are paying attention now. So let's see. So let's understand the concept of final versus immutable. So final is applicable for variables and immutable is applicable for objects. So what does this mean? So final variables. So if we see the purpose of final variables, final restricts the value of a variable from being changed at any future point. So if I say int a equals to 6, so what is this a? So a is a variable. So variable. So what does the word variable means? So variable means something that changes. So variable is something that changes or varies is a variable. So something that changes or varies is a variable. So we call int a as a variable. So a is a variable. It means that a's value is changeable and a's value can change. But if we want to restrict the change to a's value, we want to say that the value of a should remain constant and it should never change at any future point in the program. Then we would declare our variable a as final. So when we declare variable a as final, the value assigned to it cannot be changed. So here we see here 6 and we have variable a pointing to it, variable a. And now since a is a variable, if I create another object with the value suppose 59 and I try to change, since variable a is a variable, a is a variable, so its value would be changed from 6 to 59. So when I want to restrict this, I would make a as final. So when I declare variable a as final variable, this restricts the change in data. So if any future point I try to change the value of a, I would get an error. So let's demonstrate this in a program. So here int a equal to 6. So now variable a points to 6. Then let's just print a. Okay, so when we execute this, we get the output as 6. So variable a is now pointing to 6. Now in between the flow of program, I change the value of a to suppose 60, and then I try to print. So here a was 6 and then a's value got changed in this line here to 60. So a is a variable and its value changes. So now if I want to restrict the change of value, so I would declare a as final. So when I declare a as final, its value becomes permanent and it cannot be changed now. So even here our id is giving us an error, but let's try to run this program. So when we run this, we get an compile time error. So unresolved compilation problem. The final local variable a cannot be assigned. So as we can see, whenever we try to modify an final variable, we get an error. So a final variable's value cannot be changed. So I hope that is understood. Now let us talk about immutability. So immutability lies inside the object's nature, like string. So if I have a string object, the data as hello, then if I try to change the object's data, it shouldn't be changeable. Like in the cases of string, as we have understood that strings are immutable, which means that after creation a string's value cannot be changed. But we have also seen string buffer whose value can be changed. So if this object is a string buffer, then I can very well change it and add or remove data from it, so it can be changed. So immutability is object's nature and final is variables nature. So if we try to do something like this, so let's directly see in code. So we're creating a string buffer object. So final string buffer sb is a new object string buffer hello, and now let's try to print it sb. So yes, we are getting our output as hello. But now if I try to modify, since we know that string buffer is immutable, I can change the object's data from hello to anything. So I do sb dot append. So I just append. So So when I try to append, so now try to guess the output of this operation since SB is a final variable and the object is of type string buffer. So try and guess the output whether we would get hello world or just hello or an error. So let's run this. So we are getting hello world. So now try and understand this. Even though the variable SB is final, how could its value be changed? So the value of variable SB isn't changed. The value of object is changed. The data of object. The data inside the object here, the data that is stored inside the object is changed. So whatever happens inside the object, the outside reference which points to it isn't concerned about that what happens inside object. But what happens here is now if I try to change SB as new, if I try to reassign SB, so if I try to reassign SB and now run this program, say we are getting here an output unresolved compilation problem. The final local variable SB cannot be assigned. So I hope it's now clear that final is an object is an variable's nature and object immutable is an object's nature. So final is applicable only for variables and immutable is applicable for objects. The final variable's value cannot be changed after initialization and immutable object's data cannot be changed. So this final variable, if we have a variable a suppose, then the object this a points to cannot be changed, but whatever this a points to inside it, whatever data it has can be changed. Similarly, a variable points to a memory location. A final variable always points to the same memory location. So as you have understood here, a points to the memory location of object hello world, this string buffer object suppose. So this cannot be changed and an object is data present inside memory. So if we consider an object, then an object is some data present inside the computer's memory at some location, and in that memory it cannot be changed. So whatever is stored inside the object cannot be changed. This is the principle of immutability, and a variable cannot point to another value or cannot hold another value after initialization is the concept of final. So I hope it is understood. So now, this is just the example we saw. We created final string buffer and we tried to change the value and it worked. But since the above program output is hello world, because final means you cannot change, you cannot assign other variable to the variable, it is fixed. So let me repeat, you cannot assign another value to the variable, its value is fixed. I'll repeat again, for a final variable, you cannot assign another value to the variable, it is fixed, the value is fixed. And immutable means you cannot change the object's content after creation like a string. I'll repeat again, for immutable objects, you cannot change the object's content after creation like a string. So I hope that this is very well understood. So here's a diagram that final string buffer, we have created a string buffer object. So now if we try to reassign the string buffer object, we would get an error. We just tried this. But if we try to change the content of this object and try to assign change the data to hello world, it would very well work because immutability is object's nature and final is a variable's nature. So I hope that the difference between a final and immutable is understood. Okay, now let's take a look at the constructors of string class. So as we know, string is a class and it has various constructors. So let's take a look at all of them one by one. So we have even used one. So the first one we have is string s equal to new string. So this creates an empty string, no data. So This statement creates an empty string with no data. So if we try to print this, we get nothing as our output. So here, as we can see, we have nothing printed because it has created an empty string. So string s equal to new string creates new empty string. So now further string s assign new string, and in the constructor we pass string literal. So we have used this constructor. So let's take a look at it. So string s assign new string, and we pass the string literal which we want the string to hold. So suppose we say hello. So we have seen and used this style of constructor before. So this creates a string object with a value specified here in the construct in the parenthesis. So when we try to print this, we would get hello as our output. So this creates a string with a specified value. Okay, so now let's move on further. We have string s equal to new string buffer sv. So now let's take a look at this. String s equals to new string, and here we pass a string buffer object. Here we pass a string buffer object. So suppose we have a string sd as, so we have a string buffer object sb with the data hello. So if you want to convert it into a string value, then we could pass it in a string class constructor like this, and we would have a string. So here we are getting the output hello because the string buffer value hello got converted to a string here as it was passed inside a constructor, and then we printed it. So I hope this is understood. So now let's see another one. Here is the example. Creates equivalent string object for the given string buffer object. So example, and this is just as we saw. So now moving on. Here we have string s equal to new char. It takes a char array. So let's look at this. So suppose we have a char array. There is a, b, and c. And now if we want to convert this char array into a string, then we could just pass it directly inside the string class constructor. So string s equal to new string, and we would simply pass the char array here. So now try to guess the output of this. What would the output be? So now let's print it. So here we have ABC as the output. So all of the content inside the char array gets converted into a string. Just as we saw, we got ABC as a string here. So I hope this is clear. So this style of constructor creates an equivalent string object for the given char array. So this is the same example we saw. And now further, we have a string s equal to new string, and we have a byte array. So let's take a look at this. So suppose we have, so suppose we have 101, 102, and 103 as the data here, and we pass this byte array inside a string. So now take a pause here and try to guess the output. So what would the value of the string s be? So would it be 101, 102, 103? So would it be a string like this, or what would the output be? So just take a pause and try to guess the output, and we'll see what the output is. So when we run this, we are getting the output as EFG. So why do we get this output EFG, and what is this? So let's understand. So there is something called Unicode. So all of our keyboard characters we have on a keyboard are represented as integer or numeric values inside a computer. So our computer has a mapping that it has substituted the letter A with the value 97, B with the value 98, and C with the value 99, D with the value of 100, E with the value of 101, F with the value of 102, and G with the value of 103. So these are byte type values. So yeah, our byte had 101, 101, 102, and 103. So these got converted into their equivalent characters. So as we can see, our output is EFG. So EFG is E is 101, F is 102, and G is 103. So here the character codes passed inside this byte array got converted into a string. So just for your knowledge, the lowercase start from 97 and uppercase character starts from 65. So here instead of this, if we give 66, 67, and 68, we would get B, C, D as our output. So 66 would stand for B, 67 for C, and 68 for D. Similarly, the valid range of Unicode characters is still from 1 to 128. So from 1 to 128, we can enter any character here, any code here, and we will get its equivalent characters. So we can even try entering some non-alphabetic like 23. So let's see what's the output of 23. So we get this symbol here, the question mark symbol as our output. Let's try some another value. Let's try 10. So for 10 we got nothing, so it might be something, some character which might not be displayed, or it might be a blank character. So now let's try 15, and here again we got the same character. So the output which is returned, it cannot be converted into a displayable text by Eclipse. So the ID, so it's giving us this character, but you can find the mapping if you want to online, so you can give it a look. And so that's it. We have taken a look at the constructors of string class. I hope you understood everything that was taught.